All right, we're moving on to the next building block or the black box we're going to talk about. We just finished up the multiplexer, and now we're moving on to the decoder. Now, the decoder can have many different applications on how it can be used. And in actuality, the word decoder is kind of generic. I'm giving here a basic definition, and the basic definition is a block with fewer inputs than the outputs. Now, we had kind of already started to build up a decoder. In your simulation project you're currently doing, we had that we were going to create a 7-segment LED decoder, where in this item we had our input. We had 4 bits, which we were going to treat as a 4-bit number. And on our little display, we had a 7-segment LED, and we wanted to show the numbers 0 through 9, and then A, B, C, D, E, F. They get the full 16 combinations. Now in here, we had, 4 inputs being mapped into 7 outputs. This gives us the idea of a decoder. For any given value of input, they're going to have one value of the output. Now, we got a very special type of decoder, which we're going to discuss today. And that decoder is what we're going to call a line decoder. It's going to have a very fixed binary output. So as our line decoders go from N to 2 to the N of a line decoder, we're going to have a very predictable output that's going to be produced. So if we go N to 2 to the N, the examples we're going to have is 2 to 4, 3 to 8, 4 to 16, then we go 5 to 32, 6 to 64. So they can keep growing in size. So this is what's going to look like, the basic idea. So here we're going to start easy. We're going to have a 2 to 4 line decoder. And we see we have 2 inputs, A and B. We have a larger set of outputs, and I labeled them as Z0, 1, 2, and 3. Now, if we have this line decoder, we kind of need to understand how it's going to work. Now, we're not going to do a characteristic map like the multiplexer. Here, we're going to go straight out to the actual truth table that would be generated. Now, with a line decoder, this is going to be what is unique about it. A line decoder will have only a single 1 in the output. So you're not going to see multiple ones. You're only going to see a single 1. And the way it's going to be treated is we're kind of going to look at a Z with A, B as a number. You could think of this as a base 10 number. So if we did that and, we said it's Z00, well, that's the same as Z0, Z11, well, that's Z3. Okay, so that's the way we're going to treat it. And it's going to be, that's the value that is a 1. So our very first input of 00, that's the number 0. So Z0 gets a 1. And then the remaining ones are going to get a 0. Z of 01, well, that's the number 1. So Z1 is a 1, and all the rest are zeros. Then the next number will be 2. So that gets a 1, and the rest get zeros. And then our final one is 1, 1, which is 3. So 3 gets a 1, and all the rest get a 0. And we can keep treating our numbers like this, the line decoder. That's the way the output is generated. So here we have another output, another example. We have the 3 to 8 line decoder. And in this one, we're going to have 3 inputs, A, B, C. And we're getting out, 8 outputs, a Z0 all the way to a Z7. So let's look at the truth table. Let's try to figure this out. So we have the input of 0, 0, 0. Well, that's Z0. So everything else would become our 0. 0, 0, 1, that's the Z1. 0, 1, 0, Z2. 0, 1, 1 is Z3. 1, 0, 0 is 4. 1, 0, 1 is 5. 1, 1, 0 is 6. And then 1, 1, 1 is 7. And, we can just fill in the rest of the truth table. So it's a very predictable type of output that we're going to be producing. Now, this is going to have unique circumstances on when we're going to use it. We're going to show one example towards the end of how we would use a line decoder for like Boolean expressions. You can also use a line decoder as if you were going to transmit information, between, let's say, one chip to another chip or one part of a chip to another part of the chip, where if we needed to transfer like 8 bits of information and all of them only have a single value of being 1, instead of using 8 wires, we will go through uh, a line decoder here so we can kind of reduce it down to 3 wires. Okay, so now that we have an idea of how it works, the next big question is, how do we build a line decoder? Here's our 2 to 4. I did it as a black box. Here's our little design here. And this is good that we can have this on paper. We know how it's going to work. We can draw out our circuit, but at some point we're going to have to create it. So how will we go create it? Well, we got our truth table. And this is very simple. It's truth table, goes to K-maps. Now the K-maps in this setup, we don't really need to create a K-map because there's only one value that has the value 1. So let's just say we look at Z0. We're looking at what value gets us a 1. What is the A and B? Well, I just figure out what that has to be as a equation. So here, if I did as sum of products, then this is A bar, B bar. Then I can grab the next one, Z1. What's the value going to be? Z1 is A bar B. Z2, we look at that. We say Z2 is A, B bar. And then last, we got Z3, which is in this light blue color. Z3 is AB. And that's the circuit. All we got to do is all of this is found inside the circuit. Now, if we look at this, I want to ask another question. What does this output remind you of? Anybody have an idea of what the line decoder output looks like? We've seen it before. Well, if we look at this, all of this for us is midterms. Each of these I can say, what is Z0? Well, that's midterm 0, midterm 1, midterm 2, and midterm 3. Well, what is this going to mean for us? Well, it's kind of unique here in that what we could do is, because the line decoder gives midterms out, we can use it to create a Boolean expression. So let's do an example here. And what this could help us save is, if I was, had a breadboard, I wanted to build a circuit, going down to all the sum of products or product of sums, that could be a very big number of chips. The breadboard will be pretty large. We can get it a little bit smaller. So let's say we have 3 outputs we want to produce, an S, a T, and an R. And S, we know that it is midterms of 0 and 1. T is midterms of 1, 2, and 3. And R is the midterms of 2 and 3. So let's just say we're going to do a 3 output circuit. All right, so we're going to do a 3 output circuit. Let's say this is going to be, because we look at the numbers, and I would say, okay, that's an F of A, B, and C. So we're going to have, oh, not A, B, and C, A and B. So we're going to have 2 inputs. Okay, so then let's take our 2 to 4 decoder. My inputs are A, my input is B. Okay, so we have that as our input. And we're going to produce out Z0, Z1, Z2, and Z3. Now, I can also say, let me just flip these to M's. M0, M1, M2, M3. All right, so let's start with S right here. That should be highlight. Let's start with S. Okay, so I want to build S. I want to have this be an output. And I know it takes M0 and M1. We're going to take M0, put that into an OR gate. I'm going to take the M1 output, put that into OR gate. And look at that. I created the value of S. I want to look at T now. Well, T is again going to be an OR gate, and it needs 1, 2, and 3. So I'll just connect on to 1, and then I'll take 2, and then I'll take 3, and I built that T output. Then let's go to our last one, R. I want to produce this R here, so another OR gate with R, and I need 2 and 3, so I'll just connect on to the lines of 2 and 3. And look at that. We made our Boolean expressions. And this will be very compact. You know, if we wanted to build this on a breadboard, likely this is just 2 IC chips. One IC chip for the decoder. And then usually on an IC chip for OR gates and AND gates, you usually have 4 gates themselves. So you can easily see that we can build this with just like 2 chips. All right, so this gives you an idea of a bigger, black box as we start to do modular type of design. We talked about line decoders, which here are going to produce the predictable output, only 1, 1 on every single value of input. Or we can take it to like a very generic attempt of a decoder, just like this 7 segment where I'm going to produce, more outputs than what the inputs were. All right, so we're almost done with all of our different building blocks we're going to look at. The next one will be our priority encoder.